Scientists have developed a shorter method to express very large numbers or very small numbers. Um, the method is called scientific notation. Okay, so let's have a look at scientific notation. If you had a number that looks like this, 130, and we're going to make it worth our while to use it in scientific notation. Now, if you were dealing with large numbers like this on a regular basis, excuse me, then that would be very time consuming. So what scientists have come up with is a method used to express this very, very big number into scientific notation. Scientific notation is based on powers of the base number 10. The first number is called the coefficient, and it must be greater than or equal to 1 and less than 10. So that's where we're going to get this here. And the whole idea, m times 10, there's my base power, base number 10. So there's where this comes from. Now, m is your coefficient, and this coefficient is your number that's between 1 and up to 10. And this value here, this tells you how many, now there's your decimal, not written in, but I'm going to put it there. Now there's where your decimal is. This number here is going to represent how many places we have to move until we find ourselves between 1 and 10. So let's have a look. We start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So they're on between 1 and 10. And I would express that very large number in scientific notation, and it would look like this. 1.23 times 10 to the 11th power. Same goes, or the same rule applies if you are looking at a very, very small number. Same idea, your coefficient, your base power of 10, base number 10, and your exponent. Now, this time, there's where my decimal is. It's quite clearly there. These are all, we just did a lesson on significant digits. These are not significant, but they are important because they let us know how small this number is. We'd say there's two significant digits here. I'm getting sidetracked, but that's just to give you a little added information. I'm going to move this decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots. So I would say 1.7 times 10. Now, because we are moving our decimal to the right, and our number is very small, we express that exponent as a negative, and we would say 1.7 times 10 to the negative 10. We moved our decimal 10 spots. This one over here, we moved our decimal 11 spots. When you are moving your decimal to the left, your exponent is going to be positive. Obviously, because the number is a big, big number, therefore this is going to be represent this as a big or a large number. And of course, because we are moving our decimal to the right, it is representative of a very small number being expressed into scientific notation, and therefore our exponent is going to be a negative. Okay? Thank you, and have a great day.